Assalamualaikum and hi, my name is Arif Ilman bin Zulkarnain. My matrix number is DE200114. So I'm doing question 1. So this is the MATLAB simulation for question 1A. As you can see, this is the formula that I've been put in the MATLAB and I'm gonna run it. So this is what I get from using the simulation. So this is the answer for question 1A. For question 1B, so this is the uh, simulation. So now we're gonna run it. And this is the answer for question 1B. Okay, next for question 1C. This is the coding and then we run it. And this is the answer for question 1C. So that's all from me for question 1. Next, my friend's gonna talk about question 2. Thank you.
Okay, hi, my name is Putri Celia. So I will explain to you about question 2a. Determine the solution of y double prime minus y prime equal to exponent to x minus x plus sin x using the method of undetermined coefficient. So all coding. So first thing first, I put the InSoft interactive there will be appear the box, so you click the edit and add the equation. So I put the y double prime, so y respect to x and the power of 2 because it's double prime. So I insert and then I insert the y prime power of 1, so I insert, then click down and I just insert the equation. So y double prime minus y prime, y double prime minus y prime, and then equal to exponent to x minus x plus sines x. So add, and then this is the equation, and then we click done. As you can see, it entered the different equation here and then click solve symbolically and then click solve and you get the result. So the result ys is seems like this, 1 over 2 e exponent to x. So here you can get this, and then aex plus b, we get c1 exponent x, c1 as a and c2 is as b, and we have 1 over 2x power of 2. Here we have 2, as you can see here, and we get as minus plus x, so got plus x, And then we get 1 over 2 cos x and minus 1 over 2 sin x. So at here we can 1 over 2 cos x and minus 1 over 2 sin x. So move forward to the question 2b. Okay, now I will explain about question 2 part B. Show that using a variation of parameter method will produce the same solution as Q2. So the equation is y double prime minus y prime equal to exponent to x negative x plus sin x. So I'm gonna using a maple. So first thing first, the equation coding at maple is equation is dy or y double prime minus y prime equal to exponent to x negative x plus sin x. So I will determine the fx. So you can see the fx is exponent to x negative x plus sin x. So I put it here, the fx. Then y1, I will determine the exponent x because y1 is exponent x and y2 is 1. So I determine this 1. And then use a formula for w, which is, as you can see, is multiply with 0 and multiply with 1. So I get it as an x. And I do the same, like y1 multiply with differentiate y2. So this is the result. And then I determine the w, so I simplify it, then I get this, the result. And as you can see, I got the result, and I have to find a u and v. So first thing first, in this coding, I just take out f1. So f1, I'm just make a y2x fx over wx like this. And then after that, I simplify and I integrate. So as this coding, after I put the f1 and then I simplify the f1 and then I integrate f1 x, and then this is the result. And same as f2, I put here f2 and then simplify the f2 in here and then v integrate. So this one I will v integrate the f2. Okay, and then this is the result for the yx. Negative y1x multiply with u and plus y2x multiply with b, and that's the result. And this is my result for the whole equation for question 2b.
Okay, Assalamualaikum. My name is Muhammad Haikal Najmi bin Helmi. My metric number is DE200100 and I will proceed with question 3. So this is for the question 3. Okay, for question. Okay, so this is my manual solution that I've done here. Okay, so first So now we talk about the simulation. So for the question 3, first step first, we need to do the metric form. That is y equal to ab plus g here. Okay, so that we assume a is a metric form. Okay, so after that, step 2, we need to find the agent value. So okay, so after this, after find the agent value here, we have two equation 1 and equation 2. So for the equation 1, we do the equation 1 to get the x1 and y1. Okay, so for the equation 2, we do the equation 2 here to find the x2 here and y2. Okay, so after that we substitute here, and then for we need to do the yc. Okay, we do the yc to generate the equation of the homogeneous system. Okay, so this is formula for yc. Okay, equal to c1 v1 here, and then we get this. Okay, so for the question B, first we need to assume the yp first. Okay, so g equal to 5/10 over 3. Okay, so after that we assume a yp prime. Okay, so put this formula, and then we get just like this. And then after that we need to compare the yp prime with y prime here. Okay, using the using this formula. Okay, so we get the two equation 1 and the equation 2. Okay, solve the equation 1 and equation 2, and then you will get the answer for B is here. Alright, so 0.5, 1.1 over 2, or for my manual solution, we will put it to 0.5. Okay, so for the C, okay, it is quite easy because of the C. They want us to formula the general solution for the non-homogeneous system. Okay, so this is the formula for the homogeneous system. Okay, so you just put y equal to yc plus yp. Okay, and then we get just like this. Okay, so for the D, okay, so for the D, calculate the particular solution for y1x and y2x with y0 equal to 1, -1. Okay, so then you just put the y0, 1, -1, and then calculate, and then we get the answer for the equation 1 and the equation 2. And then you will solve and substitute the equation, and then you will get just like this. So that's all for the question 3.